All right, so let's really quick go through this assignment. All right, the first one, you are using the fact that you have a radius here and a tangent here, right, which makes that a 90-degree angle. So what do all three angles in a triangle have to add up to? 180 degrees. So 180 minus 90 minus 58, right, would give you 32 degrees. Okay. The next one again, radius to a tangent, right angle, radius to a tangent, right angle. Now, what do all four angles in this quadrilateral have to add up to? 360. So x is equal to 360 minus 130 minus 90, which would give you x is equal to 50 degrees. Okay. Now here, right, how do we find x here? Well, if you think about it, if I draw all of these angles in, right, all of these angles in the middle will be congruent. So if I look at it, how many do I have here? I have 5 of them there. So isn't it easy just to take 360 divided by 5? And you would get all of those central angles are 72 degrees. Okay. So again here, when when tangents intersect outside the circle, you know you get these are all congruent, right? So that's going to be 8, that's going to be 6, this is going to be 9, this is going to be 16. So the perimeter, this is going to be 24. This would be 25. This is 15. And this is 14. So the perimeter would just be 24 plus 25 plus 15 plus 14. And you would get a perimeter of 78 centimeters. Okay. So over here, right away, this is 1.9, this is 1.9. Now to find this piece, what we're going to do is we're going to take the 3.4, subtract the 1.9, and that would give you 1.5. So this piece here is now 1.5, which makes this piece 1.5. Now this piece would be 3.6 minus 1.5, which is going to give you 2.1, which makes that 2.1. And now this piece is going to be 3.7 minus 2.1, which is going to give you 1.6, which makes this piece 1.6. Now to find the perimeter, I'm going to add these up. And it gives me 3.5 plus, this is 3.4, plus that's already 3.6, that's already 3.7. And when I add these up, I get a perimeter of 14.2. Okay. Next one. It says, if this is a perimeter of 88, how can I find QY? So this is what we're trying to find. Okay. Well, right away, I'm going to mark everything I know. That's 15. That's 17. Right? What I don't know are these two pieces. But right away, if all of these pieces have to add up to 88, right? I'm going to say 88 minus 15 minus 15 minus 17 minus 17, right? What does that give me? 24. So all of these pieces, right, make up a certain part. So when I do the 88 minus 15 minus 15 minus 17 minus 17, I get 24. And if we know these pieces are congruent, QY is just going to be 24 divided by 2, which is 12 units long, which makes that 12 units long. Okay, how do we find the circumference and area of this circle, right? In order to find that, we have to find x, right? a radius and a tangent make that right angle. So if I look here, right, I'm going to do Pythagorean theorem, x squared plus 10 squared, and remember, this hypotenuse is going to be x plus 7 squared. Now don't forget, right, it's going to work out nice again algebraically when I distribute that x squared plus 7x plus 7x plus 49. I'm going to get x squared plus 14x plus 49. So x squared plus 100 equals x squared plus 14x plus 49. But again, generally, when we go to set this equal to 0, the x squareds cancel out. And we have 14x plus 49 equals 100. When I subtract 49, 14x equals, it's going to give you 51. And when you divide by 14, you get 3.6. Okay? Now, this does work out ugly, but the circumference now, if x is 3.6, that tells me my radius is 3.6, which means my circumference is going to be 2 times pi times the radius. So 2 times pi times 3.6 would give you 7.2 pi. Now the exact answer mine's going to be is approximately 11.4. Now the area, remember, is pi times the radius squared. So pi times 3.6 squared gives you 12.96 pi. And if you multiply that out, you get approximately 40.7. That'd be centimeters squared. This would be centimeters. Okay? A little ugly, but not hard. Okay, number 8. In the diagram, zy is tangent to circles O and P. Find the value of x. Right? So if we want to find, this is like that distance between the centers. So if I go ahead and I draw this line parallel to this, I create this rectangle here, where that tells me this is going to be 9. This could be 25. Now the key here is to find this part here. Because remember, a radius and a tangent is a right angle, which makes that a right angle. If I do 12 minus 9, that tells me that piece is 3. So if I look at it now, leg squared plus leg squared equals the hypotenuse squared. So 9 plus 625 equals x squared. X squared equals 634. And when I take the square root, right, you're going to get about 25.2. Okay. Similar problem here, right? But it's asking what is the length of the common tangent. When they say that word or phrase common tangent, they're talking about this segment here. Well, it's very similar to what we just did. I'm going to draw this line in parallel, right, to this. That gives me my right angle here. This piece now is 6, which is going to make this 7. Now, we know this whole piece is 25. And now if I use Pythagorean theorem, I'm going to call this x. And remember, these pieces are equal, so once I find that, so leg squared plus leg squared equals hypotenuse squared. X squared plus 49 equals 625. X squared equals, right, 576. And when I take the square root, x is equal to 24. Okay. So for number 10, they tell you the diameters of circle A, B, and C are 10, 20, and 14 respectively. Now, when you think of it, if the diameters are 10, 20, and 14, what you have to know is the radius is going to be 5. This radius is going to be 10. This radius is going to be 7. So right away I know this radius is going to be 5. This radius is going to be 7. Now, this radius, right, is going to be 10, but this diameter, remember, is going to be 20. They want us to find, right, the length of XB. This is what we're looking for. Okay, well, think about it. If this radius is 10 and that's 5, you know right away that this segment is going to be 5. So right away, we see that XB is 5. Now, BY, what you have to understand is if this radius is also 10, 10 minus 7 gives me that's 3. So BY, I don't know what happened there. BY is 3. And then right away, XY, XY would just be 5 plus 3, which is 8. And now AY is going to be the 5 plus the 5 plus the 3, which gives you 13. Okay? So, that's that. Okay? And then, number 11. Here, you have a right triangle. So that's 3, that's 4. You know right away, if you remember your Pythagorean theorem, or triples, that's going to be 5. So all I did was use Pythagorean theorem, right, to get that this is 5. So now to find the area, if the diameter is 5, I know the radius is 2.5. So the area would be pi times 2.5 squared, and 2.5 squared gives you 6.25 pi. So that would be the area, and that's feet squared. And the circumference will just be diameter times pi. If your diameter is 5, you would just use 5 pi. Okay? All right, number 12. This goes back to yesterday's lesson. If I find all of these right away, if that's a right angle, this is a right angle, which means that this angle is going to be 90 minus 67, which gives you 23 degrees. So angle this should be a COA is going to be 90 degrees. Angle COB we said was going to be 90 minus 67, which is 23 degrees. Arc AB is then going to be 67 degrees. Now, arc B, and here's the thing, when you go from B all the way to D around to A, right, you're either going to add up all of these arcs, or the easiest way we said the other day was to do 360 minus the arc we are not including, which is 67, and 360 minus 67 gives you 293 degrees. Arc EA, you know, is 90. Then arc A, right? So let's do this. Let's do this in green. So I'm going to find arc A to B all the way to E, right? If you look, that's just going to be 360 minus that 90 degree angle we didn't include, which is 270. Arc DE is 90. Arc CE, if I look from C all the way to E, that's half a circle, so 180 degrees.